Welcome to our presentation entitled Dark Fibre, SDN and Network Agility, leveraging the UK opportunity for faster service turn-up, cheaper connectivity and user control. My name is John Mitchell, Director of Product Management at Sorrento Networks, part of the Comtech Group. Not so long ago there was a UK catchphrase TV game show where contestants were given the first word in a two-word couplet and asked to guess what the most popular second word was by public survey. For example, dark net, dark hedges from the Game of Thrones blockbuster, dark side, obviously from Star Wars. Questions for the least popular choice, dark fibre. Actually, fibre has been the focus of a lot of activity in the UK regulatory space of late. In April 2016, Ofcom published their long-awaited Business Connectivity Market Review, where one of the big ticket items was the mandate for Openreach to make BT's dark fibre available to third parties beginning the 1st of October 2017. This was followed by last week's Openreach announcement whereby Ofcom and BT agreed Openreach to be a separate legal entity. Also this month the UK government published its UK digital strategy document to quote, "We believe that the future of high-speed and high-quality connectivity lies in deeper, more extensive fibre networks. To promote this, we will invest £400 million in a new digital infrastructure investment fund, which had been first referenced in the Chancellor's 2016 autumn statement. Also the reference to public-owned or funded networks such as research and education networks and Network Rail being leveraged to increase fibre connectivity and backhaul infrastructure. And lastly, also in the November autumn statement, a new 100% business rates relief for new full fibre infrastructure for a 5-year period. Dark fibre is coming out of the shadows. Thinking back at the higher level, what connectivity options are there today for enterprises, utilities, data center operators and other service providers? Traditionally, if someone needed to connect to data centers or comm sites at layer 2 requiring bandwidth of 1 gig or greater, then an Ethernet access service would be leased from a service provider, support underlaid by Openreach or other infrastructure provider. Other less likely options are if the data center operator or enterprise has optical transponder equipment and expertise in-house to utilize a layer 1 wavelength service or layer 0 dark fibre service to reduce connectivity lease costs. So what are the demarcation points and differentiation between these different types of services? For the layer 2 Ethernet service, the data center operator or enterprise simply plugs their Ethernet cable into a service provider switch port and leaves the service provider to manage the switch demarcation point, the transport of the traffic across the service provider's network from A to B, and termination of the traffic on the service provider's to client switch port. This is a comprehensive but expensive service in terms of installation, service lease and any A to B distance costs. The wavelength service operates on a per wavelength channel basis, where the data center operator has the opportunity to aggregate client traffic at layer 2 or multiplex traffic at layer 1 to a higher bit rate and hence increase utilization of the service provider's wavelength channel they are leasing. This negates the leasing of multiple numbers of Ethernet services, but must be traded off against expertise and equipment cost of in-house layer 2, layer 1 equipment. The dark fibre service offers the greatest client flexibility and opportunity for cost reduction on connectivity services. Having access to a dedicated fibre means that the client can leverage the benefits of wavelength division multiplexing at layer 0, effectively operating multiple wavelength services under dark fibre lease cost. Of course, a data center operator who utilizes layer 2 Ethernet services for connectivity today can accumulate the benefits of layer 1 and layer 0 in one combined connection migration from layer 2 to layer 0 and gain a very significant cost reduction multiplier. Moving from a layer 2 connectivity service not only increases wavelength capacity whilst reducing cost per bit transport, it offers some other significant propositions. Going into a layer 2 network, you're just another client's traffic in a sea of other customer traffic, traversing multiple hops and equipment nodes, each with their increased probability of failure, outage, and each hop increasing latency. A direct layer 1 or layer 0 service cuts through the paradigm of electrical switching into the photonic domain, decreasing latency, and service availability figures are improved significantly. What does dark fiber look like at the physical layer 0? The interconnecting protocols of Ethernet and fiber channel have to be transported over physical media. For short reaches between equipment racks and aisles, copper interconnect is used. For longer distances, especially at higher data rates such as 1 gig, 10 gig and above, optical fiber is required. Multimode fiber is suitable for intra-building connectivity up to 1/100 of meters in length. For inter-building or across metropolitan, national or international geographies, single mode fiber is required, which can support optical transport over 1/1000 of meters or kilometers. Graphic shows bundles of optical fiber in a single fiber cable form, which may be laid in duct or directly buried. Cable forms may contain up to 144 or more individual fiber strands. These optical fiber cable forms may be directly buried, located in buried ducts, and presented at the interconnection points in POPs, street cabinets, vaults or other equipment rooms. Projected cost of a typical dark fiber access service is roughly the same price as a 1 gigabit Ethernet EAD service from OpenReach, minus the cost of the equipment and some other factors. Though still a costly resource to lease, once deployed, the opportunity to maximize the data capacity that can be transported over the fiber strand migrates from the control of the service provider to the dark fiber access customer. Increasing line rate is an effective solution whereby the means of electrical multiplexing multiple lower rate signals can be mapped to a single higher rate signal, such as 10 1 gig data rates to one 10 gig data rate, offering one dark fiber service effectively doing the work of 10 1 gig Ethernet EAD services for the same baseline cost minus equipment. There are a number of electrical multiplexing schemes. Ethernet switching at layer 2 or OTN switching at which is 100% deterministic and guarantees zero data loss. Bandwidth capacity per fiber can be further increased by multiplexing additional individual wavelength channels in an optical fiber. With each transponder transmitting a different wavelength of light, multiple wavelength channels can reside on the same fiber. The number of channels that can be supported per fiber is a factor of spectral width and the spacing between the wavelengths. Typically, a 100 GHz spacing supports 40 channels, and the narrower 50 GHz spacing supports up to 80 channels per fiber. As an example, deploying 40 channel wavelength division multiplexing turns a single dark fiber access service into 40 virtual dark fiber access services, as at no extra cost than the addition of the WDM equipment at each end of the link. Combining electrical and optical multiplexing leverages the cost reduction multiplier effect, where the cost per bit carried over a dark fiber access service declines almost exponentially. In this example, 10 port muxponders deployed on a 40 channel WDM system supports up to 400 gigabit Ethernet services per dark fiber access service. As an example, deploying 40 channel WDM turns a single dark fiber access service into 40 virtual dark fiber access services at no extra base cost than the addition of the WDM equipment at each end of the link. If we project these solution options on a cost curve graphic, we see standard Layer 2 Ethernet access service as a fairly flat cost curve, with increasing bandwidth where 1 gigabit Ethernet EAD are cumulatively added as bandwidth growth demand rises. Utilizing a wavelength service where the user has control on the Layer 1 equipment incorporates step change in the cost curve where electrical multiplexing is deployed. The real savings are exposed when a DFA dark fiber access service is deployed for higher bandwidth demands, where another step change in the cost curve is effective with wavelength channel multiplexing in the optical domain. Of course, these cost curves are only typical, and detailed comparisons are needed for each real-world scenario. In all cases of wavelength and dark fiber access, the initial cost is always higher than a Layer 2 Ethernet service, for example, due to the first-in cost of the Layer 1 optical equipment. Also, there are operational costs associated with running and maintaining your own Layer 1 optical equipment. But in all cases, a business case analysis will show the cutover point and payback period. Owning and running your own optical Layer 1 service also opens the possibility of adding Layer 1 value-added services typically only available to Tier 1 and Tier 2 service providers. One of the highlight service requirements in getting data from A to B in the Layer 0 and Layer 1 domain is the increasing threat of security breach on the physical fiber by externally tapping the fiber in an external connection or splicing closure or even within building. To maximize fiber security, transponders and muxponders are currently being offered with integrated encryption engines. This hard AES 256 encryption with key exchange occurs at native line speed, so traffic latency is kept to a minimum and 100% of the traffic is secured, not just part of the payload as occurs in Layer 2 or Layer 3 encryption techniques. One item that makes users nervous of optical are the analog factors such as attenuation, dispersion, talk of dBs, signal to noise ratio, power levels, etc. These factors do not normally add complexity in access and fiber metro topologies. Rather, these factors are important considerations in regional and long-haul optical networks exceeding 80 km span lengths. In scenarios where there are requirements to amplify and or compensate on the dark fiber access environment, smart design tools guide to the addition of which components need to be added. These are passive one-time fit and forget components which do not add any operational complexity. Owning and operating Layer 1 equipment is not as scary as it may have seemed in the past. For simpler point-to-point configuration, training and competence is not beyond the typical ICT department. There are also plenty of managed service and NOC maintenance service providers to help. The drive to SDN and managing multiple layers of equipment types means the typical and often complex traditional management platforms for telecoms equipment can now be managed from the applications layer, enabling enhanced services such as bandwidth in demand, schedule services, live real-time network performance stats, all accessible by the user where required. You may have seen Darkseid walking around to show Darth Vader and some of the stormtroopers. Here's a nice quote from Obi-Wan Kenobi. "It takes strength to resist the dark side, only the weak embrace it. It is more powerful than you know." I trust this high-level overview has emphasized the power of dark fiber for your present and emerging requirements in a rapidly changing technology and regulatory environment. We can reword the quote from Obi-Wan Kenobi. "It takes strength to resist dark fiber. It is more powerful than you know." Sorrento Networks is here to help and support you to understand dark fiber and how our Gigamux Layer 1 optical equipment portfolio under your control can leverage disruptive cost savings and transformational feature and bandwidth enhancements. Thank you.